In this last of the three types of conservation of momentum problems, we are going to look at explosions. Explosions are a little different than inelastic or elastic collisions. In explosions, we're having the objects start at rest and then separate out from one another. They will move in opposite directions. And so this is very similar to the case that you're doing in the conservation of momentum lab, where you have the two cards together and you press the plunger to cause them to separate apart. Both objects are initially at rest, so their initial momentum will be 0. So the total momentum of both before and after the explosion is 0. So we can rearrange this equation this time as 0 equals m1 v final 1 plus m2 v final 2. Because we know that the two objects have 0 momentum to begin with, and then the two momentums added together still must equal 0 due to the law of conservation of momentum. So let's look at a couple examples of these. For these, I really want you to focus on trying these problems on your own first, and then looking at my examples. So for today's notes, I would really like you to set up your paper with your description of explosions up here at the top, and then when you're ready to do the problems, do problem 1 and make 2 columns. Do your work on one side, and then press play again on the video and watch the video and look at my work and put my work, any corrections you make, on the right side. And then when you're ready for the next problem, just make a line below. Problem 2, do your work, then write my work. I will expect to see notes in this format to receive full credit for this video and for the next video, which is just example problems. 4-kilogram cart and an 8-kilogram cart are compressing a spring. Upon release, the 4-kilogram cart travels at 6 meters per second. How fast is the 8-kilogram cart moving? So press pause here, try it yourself, and then press play again when you want to see my answer. So we have two carts here, the 4-kilogram and the 8-kilogram. The initial velocity of this one is 0. The initial velocity of this one is 0. Final velocity of the 4-kilogram is 6 meters per second. Final velocity of the 8-kilogram is what we're trying to find. So we know 0 equals m1 v final 1 plus m2 v final 2. So 0 equals 4 times 6 plus 0, or not 0, plus 8 times v final 2. So 0 equals 24 plus 8 v final 2 minus 24 equals 8 v final 2. So we'll divide negative 24 by 8, and we get negative 3. So v final 2 equals negative 3 meters per second. This should be negative. It should be headed in the other direction if the momentums are going to cancel out. Example 2. Calculate the velocity of a rifle's recoil after firing if the rifle has a mass of 4 kilograms and a bullet of 0.010 kilogram is fired at 300 meters per second. So press pause here, try it yourself, and then press play again when you're ready to see my answer. Okay, we have the rifle has a mass of 4 kilograms. We're looking for its final velocity. We have the bullet has a mass of 0.010 kilograms and a velocity of 300 meters per second. So 0 equals m1 v final 1 plus m2 v final 2. So 0 equals 4 times v final 1 plus 0.010 times 300. So do 300 times 0.01, you get 4 v final 1 plus 3. So we get negative 3 equals 4 v final 1. So negative 3 divided by 4 equals v final 1. V final is therefore negative 0.75 meters per second. Should be significantly slower speed because it has significantly more mass. Okay, this completes two examples of are explosion problems. In the next video, we're going to look at a number of problems that have multiple types of either explosion, elastic collision, or inelastic collision, differentiate between them and solve them.